Okay, so let's practice this example. So as we say, if we want to, for this 2 by 2 matrix, we want to find its eigenvalue. It's important problem for the eigenvalues of a matrix and how to find its eigenvalue is important problem. And it's the previous example, previous example A, and we want to find its eigenvalue and its corresponding eigenvector. But as we say, eigenvector, if you multiply by any scalar is any non-zero scalar in the eigenvector is also an eigenvector. Okay, so it's also an eigenvector if the scalar is non-zero. Okay, if V is an eigenvector, you could multiply by 2, you could multiply by 3. It's also its eigenvector, then you multiply by 2 or multiply by -3, it's still eigenvector. It's still eigenvector. So it becomes an eigenspace. It becomes an eigenspace. And for any vector in its eigenspace is an eigenvector. For any vector in eigenspace is an eigenvector. Okay, so we want to find eigenvalue and eigenspace. And how to find it? First of all, we want to decide the characteristic polynomial. Actually, just check this 10. So lambda is some scalar we should figure out. Actually, you can see the second step, solve this equation. So lambda, in this case, we could solve it. And it had its root, the root of this equation is actually the eigenvalue of A. It's the eigenvalue of A. So let's do it. So first of all, we can see determine lambda I. Lambda I subtract A or A subtract lambda I is fine. It's fine. Anyway, so determine A subtract lambda I. So it's determinant A, this guy, 3, 2, 2, 3. 3 is 2, 3 negative 2. Subtract determinant A subtract lambda I. Lambda I, what's this? Lambda times 1, 0, 0, 1. So it's subtract lambda 0, 0, lambda. It's determinant. And it's equal to determinant 3 subtract lambda 0. No. Yeah. And 2 subtract 0 is 2. 3 subtract 0 is 3. Negative 2 subtract lambda. Negative 2 subtract lambda. This one. Subtract lambda. This one. And its determinant, just compute it. 3 subtract lambda times negative 2 subtract lambda subtract 2 times 3 is 6. So just use just explain it. So share each 10. So it's negative 6 subtract 3 lambda plus 2 lambda plus lambda square subtract 6. And what's this? Lambda square subtract lambda subtract 12. So of course you should use the cross method. So it's lambda. So here is 3 times 4, and it's negative. So it should be negative positive. Yeah, this 10. And this one you will get subtract 4 lambda plus 3 lambda. So it's subtract lambda. Okay, so here you will see it's lambda plus 3 lambda subtract 4. Lambda plus 3 lambda subtract 4. Yeah, and so second step, solve this equation. It means that solve it. So second step, solve this one. Solve determinant A subtract lambda I equals 0. But determinant A subtract lambda is exactly this one. Lambda plus 3 lambda subtract 4. So it means that lambda equals negative 3 and 4. And it's exactly the eigenvalue of A. The eigenvalue of A is exactly negative 3 and 4. Yeah. And in the process, you will see this kind of matrix. If this matrix you solve it, you could figure out the eigenvalue. And after that, we could check the eigenspace. But in this step, if you see, I consider a matrix B, and the matrix B, if the matrix B is a diagonal matrix, for example, it's 3, negative 2, then what's the determinant B subtract lambda I equals 0? What's this? If I consider another matrix, this one, And we can say determine B subtract lambda I equals 0. So what's this? It becomes 3 subtract lambda. Lambda I is lambda 0, 0, lambda. So it becomes 3 subtract lambda, negative 2 subtract lambda, 0, 0, their determinant, this one. So if I consider this example, you will see it's exactly diagonal matrix. So it's there 3 subtract lambda, negative 2 subtract lambda. So if it's equals 0, it means lambda equals 3, lambda equals negative 2. What does it mean? It means that if the matrix is diagonal matrix, then its eigenvalue is exactly diagonal entry. The eigenvalue is exactly diagonal entry. But if it's general case, A, B, C, D, then of course you should compute it to get the eigenvalue. Okay? Yeah, and once you have the eigenvalue, you could check each one. But we have 2 eigenvalues, so you check it 10 by 10 to get the eigenspace belonging to the eigenvalue. So now we should check it 10 by 10. So we should solve this one to get eigenspace. Okay, so here, the first one, if lambda equals negative 3, and we should solve this equation. So we should solve it. Lambda equals negative 3, so we should consider A subtract negative 3i. A subtract negative 3i. This matrix is solution set. It's null space. It's A subtract lambda. It's null space, or you could say, actually it has a name. It's called eigenspace. It's called eigenspace. For its eigenvector, it spans a space. So and we call it eigenspace. So A subtract negative I, A subtract negative 3i. So for this matrix, what does it mean? It means A plus 3i. So what's the matrix? A, this guy, plus 3i, so it's 3, 2, 3, negative 2, plus 3i, so it's 3, 0, 0, 3. Identity is 1, 0, 0, 1, so it's this guy. So what's this? 3 plus 3, 6, 2, 3, 1, this one. Okay, so for this 2 by 2 matrix, we should figure out its null space. So what's the null space? Null space means that A0 is solution set. This guy 0 is solution set. So you should consider 6, 3, 6, 2, 3, 1. 6, 2, 3, 1, 0, 0 is solution set. This guy is solution set. So and what's the solution set? It's easy to see. Negative 2, then you could cancel it, right? We have 3, 1, 0, and then negative 6, it becomes 0, negative 2, it becomes 0, 0. So actually, we just have one equation. I mean, we just have one non-zero row. And for this part, we just want to figure out its eigenspace. So we don't need to get the reduced row echelon form. I mean, this form is enough because we have already cancelled one row. And here is our x1, x2. So what does it mean? It means that for its solution set, it satisfies 3x1 plus 1x2 equals 0. It's just satisfy this equation, right? For this one, we could not say anything, okay? We could say nothing. And here, we just have this one. And what does it mean? It means that x2 equals negative 3x1. Negative 3x1. So, what's the eigenspace? The eigenspace for the eigenvalue negative 3. For the eigenvalue negative 3, its eigenspace is, let me write down. So what's this? So null space of A subtract negative 3 is plus 3i. It's exactly x1 is x2 is negative 3x1, and x1 is any real number, right? This one, and this guy, and here it's exactly this one is exactly the eigenspace of A, belonging to eigenvalue equals negative 3. And the second And then we still have another eigenvalue, lambda equals 4. Lambda equals 4. So again, use the same way, a subtrate 4i to figure out if a subtrate 4i is it's null space. Its null space is the eigenspace of A. So what's the A matrix A subtrate 4i? It's 3, 2, 3, negative 2, subtrate 4i, 4 times 1, 0, 4 times this guy. So it's 4, 0, 0, 4. So it's exactly 3 subtrate 4, 2 subtrate 0, 3 subtrate 0, negative 2 subtrate 4. This one. This one. So now, similar, we want to find this guy is null space. It means that we want to find negative 1, 2, 3, 6, negative 6, 0 is solution set. 3, this guy is solution set. We want to find solution set. It's the definition about null space. This matrix is null space. It's A, B, it's null space means that null space of a matrix, null space of a matrix B means the solution set of B0. Solution set of B0. This one. Okay? So null space of this guy means that B0 is solution set. Okay, so and again, as we say, actually if you observe, you will see negative 1, 2, 3, negative 6. So it's a multiple. This guy is a multiple of this one, just multiply by negative 3, right? So we multiply by 3, it means that we could use it to cancel it. So you will get negative 1, 2, 0, 0, 0, 0. So we get 1, 0 row. So we just have this row. I mean, it's enough to write down its solution set. Because in this case, it means that negative x1 plus 2x2 equals 0. Negative x1 plus 2x2 equals 0. So you could write down its solution set. x1 equals 2x2. x1 equals 2x2. So what could we say? Null space of A. Let's see. So it's null space. Null space of A subtrate 4i is exactly equal to x1 is 2, but x1 is 2x2, x2 is any real number. x2 is any real number. This one. Okay, yeah. So it's the eigenspace of A belonging to the eigenvalue. Belonging to the eigenvalue lambda equals 4. So for the matrix A, it has 2 eigenvalues, negative 3, and 4. But for eigenspace, negative 3 its eigenspace is this one. It's the span, and it also means that it's the span of 1, negative 3, and then it's the span of 2, 1.